Okay, and welcome to this video. So we're going to be talking on this one about when the a is not 1, but it is prime. So what that means is you're not going to have as many options for your a coefficient. Okay, so remember two things. One, what we're talking about is ax squared plus bx plus c. We're talking about when this number is no longer 1, but actually is a value. And remember, the first step, guys, is always look for your greatest common factor. Okay? So I'm going to start off with number 17. And I'm going to look at the 8 and the 20 and do they have anything in common? And 4 will go into both. Then I look at my a squared and my a. Again, I always go with the lowest exponent, which is a to the first. So that is my common factor. It now becomes a division problem, dividing by a monomial, okay? And so the first term is going to give me a 2 and an a, and the second one a 5. Again, what I mentioned earlier on previous video was that anytime your power is a 1, you're done on the factoring. If it's more than a 1, there's always a possibility. It doesn't have to, but there's a possibility it might still factor. Okay, so that one just had a greatest common factor, and that's all you had to do. Okay, number 18. Is there anything that'll go into 5, 8, and 3? Okay, and the answer is no, there's not. And so there are two ways, actually there's more than two, but there's two ways that we talk about when a is not 1. One is just called a guess and check. Okay, so that's one method. So we're going to start with that one. And so I'm going to get my two parentheses. I'm going to, I know I have to have m and m. Okay, I've got a positive 3, so the order I'm going to do, okay, I'm going to look at my variable, get it in there. I'm going to look to my c value, and I'm going to see what it is. It's a positive 3. That means I have to have either 2 positives or 2 negatives. So then I look to here, and I say, well, they both have to be negative. Okay? So that's kind of just getting that foundation set up of what I need. Okay? Now, the next thing, if this number is prime, that means the only choice I have is for this to be 5 and 1. That's it. I don't have any other choices. 3, in this case, is also prime, which means that the only choice I have for the last two numbers is 1 and 3. Now, I could just put the numbers in there. I got 1 here, 3 here. Okay? Now remember, I have to make it equal 8. Okay? So when I do the outside and the inside, I need that to be 8. Well, in this case, it's a negative 15m and a negative m. Well, that's not 8. What that means is that my 1 and my 3 are in the wrong spot. Okay? So we're just going to take those and we're going to put them in the other spot. 3 and 1. Now we're going to do outside is a negative 5m. Inside, these two, is a negative 3, and that adds up to a negative 8, and my answer is correct. Okay? That's the guess and check way. Okay? Sometimes that is a fairly easy way. Some kids have a mathematical, what we call kind of a computational type skills, a number logic that they can kind of run numbers. If you're one of those that likes number puzzles, you might be that person. Okay? If not, I'll show you another way. Let's go ahead and look at number 19. So, will anything go into 3 and 7? No. P squared and p, and that is yes, I can just take out a p. So when I divide, okay, I'm going to get 3p minus 7. This p is now to the first power, which means I cannot do any more factoring. Okay, let's try another one. So 7, 16, and 15. Anything in common? And 7 is prime, so no. Okay? So I'm going to go ahead and get my parentheses set up. And I'm going to put my n in where I need it. I have to have a negative 15. So the only way I can get a negative is a positive and a minus. Okay, we talked about that earlier. 7 is prime. So the only way I can get a 7 is a 7 and a 1. Okay? Now, in this case, this 15 is not prime. So it actually has options, 1 and 15, 3 and 5. Now, I need it to equal, when I do this multiplication and this multiplication, I need it to be 16. Okay? 16. So, and we're subtracting. Got one positive, one negative. So, again, what you could do as a trial and error is you could just come over and put your 3 in and your 5 in. And try it out. Well, that's negative 35. And that's plus 3, and that's a negative 32, so that does not work, okay? That doesn't work. We're just going to come back, and we're going to switch the numbers. So I'm going to put the 5 here and the 3 here, okay? So now, when I do outside, I get a negative 21 in, and when I do the inside, I get a plus 5 in. And when I put those two together, I get a negative 16 in. Okay? Which is somewhat good, but not completely. Because I actually want a positive 16 in, not a negative 16 in. Very easy to fix, guys. All you have to do is change the sign. So that was positive. I'm going to make it negative now. This was negative, and I make it positive. Okay? So now the 21 is positive, and the 5 is negative, and my overall is positive. And I'm done. And again, guys, remember, factoring is just the opposite of foiling. So when you're done, you better be able to foil that problem and get back your answer. Okay. That one may or may not have been up to your liking. So let's talk about the other method that we use. Okay? And so the other method that we're going to use, and I'm actually just going to kind of squeeze in over here to the side since I didn't use much space. But the other method that we're going to use is basically the grouping method. So that was 2 videos ago, we did a grouping method. Okay? And so, let's see. I'm actually going to take and, for mine, I'm going to get rid of this answer, okay? You can leave it on yours if you want, but I'm going to get rid of it just so that we're not looking at it when we're doing this, okay? So if you're wanting to do it by the grouping method, okay, this is the steps that you're going to do, and it's also called the AC method. So you hear people refer to it as the AC method. So here's the step. You're going to take A and multiply it by C. So in this case, when I multiply it, I get a negative 135. The problem with this method is sometimes your numbers do get kind of big. Make sure I multiplied that right. 75. That's not right, is it? Is it 105? I was doing that in my head, and then I got to thinking that doesn't look right. 15 times 7. Yeah, 105. Whoop, good thing I caught myself. Okay, negative 105. Okay, so here's the steps that we're going to use. Again, I am going to take a negative 105 this time, okay? And I am going to find its factors, and I want to find the factors that give me a 16, okay? So I'm just going to start through. One has to be positive, one has to be negative. And guys, you know, I go ahead and I write 1 down, but rarely do you do the 1, especially when we've got such big numbers like this. There's no way 1 and 105 is going to give me 16, okay? And probably not 2. That would, well, 2 won't even go in there. Will 3 go in there? Yeah, 3 will go in there. So 3 will go in there. 3, is that 33? You guys always double check my math. because, I get home usually here in the 35. I get home here in the evenings and my brain stops functioning. It doesn't function in class either, but definitely here at night. Okay, where am I at? So again, as I'm doing it, I'm kind of mentally adding these up. And so far, I'm not close to 16. 4 obviously won't go. 5 will. 5 will go in there, and I'm at, what is that, 21? And add those up, 8, bingo, I get 16. Okay? So that's what I'm going to use. Here's what we're going to do, guys. And this goes back to FOIL. Again, everything kind of goes back to FOIL. If you'll remember, we got this number by adding our outside and our inside. Okay? So what we're going to do is we're just going to go in the reverse direction. We're going to break this apart. And instead of 16, I'm going to put in a negative 5 in. I put my in on there. And a 21 in. Okay? Now, I want you to pay attention to what I just did. Look at this. Look at this. That is just a substitution. That's all that is. So I substituted what I found here for the 16. It's still exactly the same problem. 16 and 16. I have not changed my problem. Okay? Now I am back to, believe it or not, let's scroll all the way back up. I am back to the grouping method. Okay? So remember how we did the grouping. We grouped the first 2 and we grouped the second 2. Okay? Grouped the first 2, we grouped the second 2, and then I found a greatest common factor and a greatest common factor. And then when I got down here, I did another greatest common factor. Okay? So, here we go. I am going to look at my first 2. Okay? So in this case, I'm looking at these 2. And then I'm going to get a different color here, so I will go pink this time since I had orange there. So those are my 2. And what will go into 7n squared and 5n? And hopefully you think, oh, there's just an n. Okay? And I'm going to divide that. I get 7n minus 5. Okay? I'm going to come over to the 21 and the 15. And I know 3 will go in there. No variables, so just 3. That gives me 7n minus 5. Now the 7n minus 5 is common. If I mark it off, again, it's left the n plus 3. And voila, I have the same answer we got earlier. And again, the difference is this is more straightforward, mathematical, done, where the other you kind of have to guess and check and guess and check, okay? And some people like guessing and checking. Some people like this method. I'll be honest with you, when I was in, setting in freshman Algebra 1, learning factoring for the first time on that, all we did was guess and check. We were never taught an optional method on there. Now, I do want to back up and I want to show you one more thing just real quick on this problem. Okay, so I'm just going to kind of clean up my board here. Because if you'll remember, we also did the box method when we multiplied. Okay? And for some of you, you might like the box method for factoring also. So once we get to this step, because some people have trouble with this, if you just come to your box, okay, and you just put in what we just have, okay? And it really doesn't matter the order, except for, just me personally, I always put the square in the first corner and my constant down here and then my 2 n's, which is kind of how when we foiled by the box method, that's how it ended up being. So here's what you do. All you got to do is look across here, okay? So now I'm looking this way, and I'm saying, what do these 2 have in common? And they have an n in common. And so if I take the, let's go ahead and go to the next one, I guess. And so now I'm going to go to the next one, and I'm going to say, okay, what do these 2 have in common? And they have a 3 in common, okay? And so now I just kind of go backwards, because if I go that area model, if I want it to be 7n squared and I have the n already, what do I need to multiply it by to get 7n squared? Okay, and that would be 7n. The other way to do it is, let me show you the other way. Let me get me another color here. Too many colors. The other way is, now I'm going to go this way. Okay, and I say 7 and 21, what do they have in common? They have a 7. N squared and n, what do they have in common? And they have an n in common. And then I'm also going to go this way. Right, so I'm doing all 4 ways. What do these two have in common? And they have a -5. Okay, because that's all they have in common. Now when you look at it, look at what's left up here. Okay, I put a plus there, and those are my 2 factors over there. Okay? Again, it's just an organizational method. Some of you might like that. So you've got 3 methods that you can do. You can do guess and check, you can do the AC method, and you can do the box method. I don't care. It's your call. Okay? Pick which one you like. Or do a little of all 3. 21. What do those 3 have in common? 7 won't go into 58, will it? Okay, so I cannot take out any numbers. So I'm going to start setting up my parentheses. Okay, actually, I'm just going to do this full one AC because it's got such big numbers. I'm just going to do the AC method. Okay, show you how to do it all the way through again. So we're going to do AC. I'm just going to multiply these 2. So 63 times 7. And that is 441. We're getting pretty big numbers. Okay. Now, I could show you a different way. We'll just do that. So 7 times 63. We're going to do that. And again, it's 441. If you take your, sometimes you want to do 7 times 9 on that. So when you start looking at the ways that this will multiply, I could do 7 times 63, or I could do 49 times, okay, 49 because I'm taking the 7 times 7 times 9. You see what I did? Let me do that again for you. Let's start over. Let me just show you what I did. Okay, so I've got 7 times 63. Okay, whatever that is. Really what I'm doing is I'm kind of doing a prime factorization. So instead of saying 7 times 63, I could say 49 times 9. And in this case, that's my only somewhat option. I could then say, well, 49, that could be 3 times 3. And so that would be, what is that? 147 times 3. Okay? But remember, I'm trying to get to 58. And so when I did the 49 times 9, and I need it to be a positive number and add to give me a negative, I could take negative 49 plus a negative 9, and that gives me my negative 58. Okay? So let me go ahead and write that down. So I'm just going to put in the negative 49, mn, and the negative 9, mn, and the 63. Let me get rid of this. N squared. Okay. Now, some of you are saying, I don't have a clue what you just did. So let me show you again. 441. Okay. And I want to find things that multiply and give me 441. I could start 1 and 441. 2 won't go in there. 3, will 3 go in there? 441, whoops, 441, 441 divided by 3, 147, 3 and 147, okay? 4 won't go in there, 5 won't go in there, 6 won't go in there, 7, let's try 7 in there. So 441 divided by 7 is 63. Okay, I'm still, again, looking for, those are both negatives. I'm looking for 58. I'm not there yet. 8 won't go into 441. I'm going to do 441 divided by 9. How about that? And that's 49. So a negative 9 and a negative 49. Okay? And there's my answer that I just got. So you can do that. If what I did earlier didn't make any sense, there you have it. Okay? Now I'm going to do the grouping. So I am grouping the first two, and then I am going to group the second two. What can I take out of 7 and 49? That would be a 7. I also now have an m squared and an m, so I can take an m out. That's going to leave me with m, and minus 49 divided by 7 is 7. I take the m out, but it leaves me with an n. Okay, next one. Negative 9 and 63, so I'm going to take out the negative 9. Remember, if the front number is negative, I take the negative with it. This time I have an n and an n squared, so I can take out an n. That's going to leave me with m, because this multiplies and gives me the 9mn, and 7 and an n. Oh, I missed a sign, negative. Okay, because I took 63 divided by a negative 9. There we go. Okay, and guys, you can check yourself, because remember, these are supposed to be the same. So now those are the same. And I have 7m minus 9n left. There's my done. I'm factored. Okay? If you want to try the box method again, I'm just going to put in and then I'm just going to start off with those. So I'm going to start with this way. And what do those have in common? They have a 7 and an m. I'm not even simplifying it. I'm just saying, what do they have in common? Okay? I'm going to go on down. What do these two have in common? They have a negative 9. Again, I'm going to take that sign and an n. Now I'm going to go north and south. Okay? I'm going to look at these two and say, what do they have in common? And, whoops. And it looks like the only thing they have in common is an m. And then I'm going to go this way, again, north and south. And what do they have in common? Looks like 7. We'll go into both of those and an n. And again, when I am done, there's my 7m minus 9n, and there is my m minus 7n. Okay? So I honestly think the box method is easier once you get this step here. Okay, I'm going to have to shut her down, because I think the next two are pretty easy. You can do those because we're getting a little long. So let me know if you have any questions.